So for the last exercise, let's discuss about the simple image classification. So image classification we can use for different purposes, uh, such as flood risk impact assessment, and then strategic urban drainage space planning, land cover change detection, and then integrated site suitability for disaster shelter. Those kind of factors we can use. Those are some few examples. So here I will give you a basic guidance on how you can do a simple image classification. Okay, first of all, to download, like, okay, where we can find the images. So for this one you can use earthexplorer.usgs.gov. You can visit this website. If you don't have an account, you can register for an account. From this website you can download free Landsat 8, Landsat 9 satellite images. So I will show you the website for brief, like for real case scenario. If you need to download some data, how you can download? First, you just need to go over there in the website, and then you can browse through. For our exercise, I download a sample image for Sri Lanka. So you can just simply zoom into the region where you want to download the image, and then you do have options from here. You can click polygon, or then you can use map or add coordinate. So if I say polygon, if I start clicking the map, then I can select region like in the Sri Lanka, and then I can select from which to when I need the image. For this example, I am not going to set. Then you can set the cloud cover. Typically we need the cloud cover to be less than 30. So for this case I will go for like 10% cloud cover. And here you can adjust the dates as well. For this scenario I am not going to select the dates, and then you can go for the data sets. From there you can select Landsat image from there. So for this case I will go for Landsat level 2, L2 combination, and then I can simply click on results. So then it will show me all the available images which I can download with the given criteria. Even you can have a preview before downloading the image as well. So for an example, if I click this one, it will give me the metadata, and even if I click, I can see the southern part of the Sri Lanka, small part of southern coast in Sri Lanka. Okay. Then when we are downloading the image, we will have 8 different formats. Let me click this button. After I click this button, it will give me the download options. From the download option, I can click 14 bands, download all files now, or select files. So I had to file download this. So I can click product details, and then I can click this simple one, file. Then it will download all the bands. Otherwise you can download bands one by one. Now what do these bands mean? If you do a simple Google search, you can see band 1 is a coastal episode, band 2 is blue, band 3 is red and green, and then band 4 is red, and then we have near infrared, and then shortwave infrared, and band 7 shortwave infrared 2. So band 8 is a panchromatic band. So if you need to pan sharpen these images into 15-meter resolution, only you can do it for blue, green, and red. So you can use this band 8. And band 9 is considered in the cloud cover. So typically for image classifications, we only need these first 7 bands. Okay, so I, instead of downloading the bands, I have give you uh, the simple downloaded file of 7 bands. So you can go to the exercise 4 and download that file with 7 bands. So you can start downloading that zip file. Meanwhile, I'm downloading that file. I can open up the arc map for the image classification. And then I can set up my directory where I save all the files, exercise 4. Then okay, arc map is loaded. So here I will close this one, click on new file, and then set up my geodatabase in size 4. Are you? Oh, okay. Use geodatabase. Oh, GTB at okay file save as size 4 04 Now I can start view the downloaded file. Then I can copy these 7 paths and then paste it in the size location. Now I can open up the catalog and then refresh this directory, and under exe exercises I can see these 7 bands. So I can drag and drop one band by one band. We select cubic convolution 77, band 4, band 3, band 2, finally band 1. Now you know what each of these bands mean. So to do the classification, first we need to create a composite. Composite means we need to combine these all the 5 bands into one single image or raster, so we can go with band combination. What do this band combination mean? So in here, if you go for this one, this is exercise, this tutorial website. Over there they mention about some band combinations. So natural color means 431. If we select 431 band combination, then we can see the true color of the satellite image. I will show you what I mean by this one. First of all, we need to select this all the band by pressing shift and then clicking from the top to bottom and select all the bands, and then go to Windows and image analysis. So this window will appear on the left side. Then from there you have to select band 1 to band 7, and then you have a small icon over there named composite bands. After that you have to click on this composite bands and then it will create this composite for you. Then you can remove this all the single band images and go with composite. So I will remove the single bands and then I will stuck with the composite. So final composite, this one you can export. Click on data and then data export. From there you can export this one into the directory. I do have my exercise EX04. From here I will say this one as incomally.tif and click. I will select EX04. And then I will give the file name as incomally, then the file format as TIFF. Compression, you can select any type. I will select none and then I will click save. Now I will remove this created composite and I will proceed with this image. Okay, so band combination mean in here you can see red, green and blue. So if I click on red, you can see band numbers from 1, 2, 3, 4, 5, 6, 7, 9, like 7 bands are there. So if I put 4, 3, 2, that means natural color combination 4, 3, 2. So for the red band, I will select the fourth band 1, 2, 3, 4, and then for the second band, I will select the third one. Then for the last one, the blue color one, I will select the second one. So now you can see the true color image. So this is the actual satellite image. So when we are doing supervised image classification, we need to select some sample areas. So now from this map, we can clearly see the water surfaces and green surfaces. So when we are selecting samples for the forest covers and water bodies, we can select some samples based on this image combination. So the other one is force color. If we go with force color, that means 764. I can select band 7, and then this one is band 6, and then this one is band 4. So if I go with this band combination 7, so if I go with 652, 5 2, you can see clearly where we do have the vegetation, that means the agriculture. So it's mean by the agriculture. So the yellow color, yellowish tint shows us the paddy land or paddy areas and the bare soil areas. And then the other combination that we can use is 764. So this one 7, This is the force color image. From this one, if you zoom in, you can clearly see regions with the you can see the vegetation, the building build-up areas in ash color, and the vegetation in blue color tint. Okay, now let's select the samples for this each image. So first I will go with true color image, which means for pause. 543 colored infrared urban force color. Okay, this is the force color composite 543. From here you can see difference. So these are the combinations that we will use. So these are the composites that we are going to color combination, band combinations that we are going to use during the classification procedure. So to begin with the classification procedure, I will close this image analyze window now. To begin with the image classification procedure, we just need to have image analysis toolbar. So if you didn't have this classification toolbar in here, you can simply right click on this any area, this empty area, and then click on image classification tab. So when you click on image classification tab, it will appear this kind of window. So in here you do have a training sample manager. First you need to click on the specific image that you are going to select the training samples for, and then you can click on the training samples manager. Now from this training samples manager, you can start adding your training samples. From here you can click on draw polygons. So first I will select the water bodies. To select the water bodies, simply I can zoom into these regions where water bodies are present, and then I can select this kind of sample. So I select one sample from here, then I can zoom out, and then I can zoom into another area. Here also I see some water body, so I can select some polygon for these kind of water bodies, and then Here also I do have some water bodies. So I select samples from there as well. Here also I do have some water bodies. I will select some samples for water body as well. And then likewise I can select multiple samples for this one specific class. So now after you selecting 10 to, typically for your accuracy, when you need higher accuracy for your image classification, you need to have higher samples. So typically you need to select at least 100 or 50 sample points for each class. But for this specific training, you select only few sample points. After you're done selecting the samples for your first class, you can simply click on this all the classes by pressing on shift, then pressing on the last class, and then you can click on this small icon mesh training samples. After that you can give your class a name. I will give this one as water, and then I will put the color for this one as blue since it is water. Then the second class also I will start by clicking this one. I will select some sample for the second class. So for this one I will select the vegetation. So vegetation, how we can select the vegetation, the samples for the vegetation. So samples for the vegetation, you can go back to band combination 4, 3 and then 2, and then you can go to the true color. From there you know this is like dense vegetation, and then over there you can select, and then from here also you can select forest cover. Here also you can select. Also I see some forest cover. So now I will switch back to band 5, 543. So from band 543 also you can see these are like denser vegetations appeared in dark red color. The denser vegetation with dark red color. And then after you're done selecting 50 or 100 samples, same thing, you can click on shift and then select these all the training samples and then merge into one class. This one I can say as vegetation. I can type as vegetation, type as forest. Simply I can type forest. Then I can select the color, green color for the forest cover, and then I have to start selecting the area for the urban regions. So here I see some bare lands. So for the bare lands you can see in ash color or white color. So these regions you can see this ash color region, these are human settlements. So I will select urban areas, this white color, or not white color, dark brown, some sort of color areas. So these areas actually we can classify it as the urban areas. These are actually urban areas. Urban areas. After you selecting the samples for the urban area also, you can select those all the samples and merge it into one class and name it as urban. Then you can select the color. Great. So next you can select some samples for vegetation. For the vegetation, we can go which band combination for the vegetation. If you are going with the vegetation, which one is the useful color combination? So if you are going something related to agriculture, we can go with 652 band combination. So from here I will select band 6 5 finally 2. So from here we can see the paddy lands in darker green color. These are actually the paddy fields. Now after selecting the agricultural areas, you can combine this by using merge sample, training sample, and type it as agriculture. And then you can select the color as yellow or something. And then the other one is bare lands. You can see there are like lot of bare lands available in these areas. That means this image was taken on some area where the harvest is finished. So you can see we do have some bare lands without any vegetation. So these are bare lands. and I will select these areas as OBIA lands. You can click on shift, select all the training samples and merge training samples and give them a name as OBIA. Select a color, I will select ash color and then you can save these training samples in the your exercise location. Save this thing as save. Also, I will create a signature file and save this one. Same directory. Yeah, I do have files saved. After that, I can click on classification and interactive voice classification. So now you can see the images we classified according to the parameters that which we have given. Now you can see some of the area of this region is identified as vegetation area, but actually we don't have any vegetation in that region. So now we need to select some sample counter that issue. So from here we can select some water samples. So I will select sample images for the water bodies from this region. You can see that region has grown and it has classified as water body area. So now there are some rules areas. This region has also identified this. You have to select the training samples for these regions and mitigate this issue. And then if you want maximum likelihood classification, you can click on maximum likelihood classification, click on trigonometry, then input the signature file which you saved previously, click on open and then click on this one, click on OK, create this classification file. It will take some time classification to do the maximum likelihood classification. It will take some time. So we can finish. I will remove the temporary classification, because when you click on maximum interactive likelihood classification, it will give you a temporary classification file. It will give you a temporary classified file. So you have to select these samples and save the signature file again. Last time I saved the previous file, so that's why it's not recognized as water body. Then if I save this new signature file and do the maximum likelihood classification again in the same signature file, now you can see it has been identified. That way it will identify this region as a water body. Now you can see it has identified this one by number 1 as a water region with a water body. So likewise you have to do the classification, and then you have to get the final results. So this will be the final result. So then temporary layers, I will export this classified data here as a TIFF file. To the same place. So for your actual practical time, you try to make more sample data. For this one, I'm not going to do a deep classification. So whenever you like select more higher sample points, then your classification will be much more accurate. This is just to show you guys that you can do something like that. Then how we can calculate the percentage of the land for each classes. So now after we have the classified TIFF, we can go to the search and convert this one into by using raster to polygon function. So now we can convert this region by using the classified raster and then values. Select class name. Then we select as classified and then click OK. Now if I open the attribute table for this one, you can see grid code is there and then the class name is there. So now I need to dissolve each class, like to get a single agriculture file and then single forest class and then single urban class. For this one, I can use the dissolve tool. I can go to the search, then click on find the tool called dissolve. Show parsing and then click on dissolve. For the input which I can put classified vector, and then I can type classified vector dissolved, and then dissolve fields optional. So this one I can type class name and grid code, and then in statistic of the field I can say and then click OK. Now if I view this files attribute table, you can see I only have these 4 classes. So for this one I can create a new field, click on add field, and then I can make this one as double and type as area underscore HA and click OK. Now I can right click on this one and click on calculate geometry. Under the area I can select the preferred unit that I want. If I need hectares, I can select hectares and click OK. So now I can have this graph, and then when I can extract this table. Now I can extract this table by using table to Excel conversion. I can select the classified vector dissolved and export this one into this location x4, scratch classified vector to table exxxl. Now it will be exported into the directory. So you can visualize this map and then show this one in interactive way using a layout, as well as you can do the same classification for multiple years. Just imagine this classification you have done for year 2020, then another classification you will find another image and you will do the same classification for year 2026. Then by subtracting these two values, then you can get to know, okay, the forest cover has been increased or decreased, whether the urban cover has been increased or decreased, water bodies have been increased or decreased. You can do a simple calculation about the expansion of the urban cover or the forest cover or where the deforestation is going on. So likewise, those kind of analysis can be done using this simple classification technique. So if you need to create more visually appealing graphs or charts, you can even use the Excel and then create something like this. Okay, I will copy this one and paste here. And then if you want to show something, put in there and visualize using simple pie chart. Okay, out of total area, how many areas like urban, water, agriculture, bare lands, like this. Then you can use these images in your final thesis or reports or those kind of things. This is the way that you can do a simple classification using ArcMap. Hope you got the main key points on this one. The major thing is when you are creating the sample, training samples, if you see, because here I know there are some mistakes. Here if you see closely, this region is like misclassified. Okay. Here you can see this region we do have water body, but in the classified image, it classified this region as agricultural area. So we need to select some more samples from these regions for the water body and then merge it into this water class. And even for the urban areas, you have to do the same thing. You have to select more samples, because I didn't select that many samples since this is a training class. So if you select more samples accurately using those band combination which I mentioned earlier, you can get a higher accuracy classified image.